Namaskar, my dear friends. Let us see a very nice solution based on GaNFETs, a very high efficiency DC-DC converter, which is going to be a 5 volt 15 amperes. So the requirement is going to be 5 volt 15 ampere. Before discussing about the PDF schematic, then bill of materials, and some of the techniques that we are going to give it to you, what we will do is we'll give you a brief idea about the design requirement and the deliverables that we will be dealing with. So in this high efficiency DC-DC converter based on GaNFETs, we are providing you 5 volt 15 ampere application, and this is a ready to use solution directly. So you will be getting schematic PDFs, schematic design files in Arcade, then we have bill of materials, and if you do need some design guidelines or something like that, design equations, that also can be delivered very easily. Some of the applications that has been recommended from the data sheet as well is like listed here. We have like industrial power supply. Some of them we are also trying to like extend our application in different sectors. uh, so military avionics, automotive sectors, we have medical devices. So medical devices and server power supply, we are utilizing this power supply. That's the reason like we have star marked them. And we have telecommunication power supply, where like servers and we have base stations where you will be able to utilize this with very high efficiency. Coming back to the design requirements, so that you can have a proper understanding about what is the goal that we have set for this particular project design. So our nominal voltage input is actually 12 volt, that is coming from a regulated power supply. Otherwise, you have a battery as well, which will be giving you around 12 to 13 volt battery. Okay, that's the reason this is capable of giving you an output for 5 to 15, like 9 to 15 volt inputs. Okay, now output is 5 volt 15 amperes. We have output ripple voltage very nice, which is just 50 millivolts peak to peak, but we could achieve less than this. The tolerance is set to 5% as a requirement. However, we could achieve up to 1% tolerance. Okay, which is just 0.05 volt, that is around 50 millivolts. The overload trip current is set to 20 amperes. So if the output current reaches to 20.25 amperes or something, it will automatically switch shut down. Okay, we are very easily achieving 0.95, that is 95% of efficiency without any heat sink or something like that. However, if you wish to, you can achieve this particular efficiency close to like 97% even in certain conditions. Okay, and the ambient temperature that it will be working on is 0 to 50 degrees centigrade. So it is very easy to work in this kind of scenarios. We have calculated complete design equations and everything. This can be also like shared based on the requirement that if you need. Okay, and you can always set the soft start timer, which is set to 6.67 millisecond. That's the reason this is what is making sure that we don't need any protection circuit or something like that for this particular IC. Now let us talk about the circuit. So from the IC point of view, which is being used is, let me just open the datasheet product page. So this is the IC that we are using, which is LTC7891 to design our high efficiency DC-DC GaNFETs converters. Okay, and as you can see, this is recommended for new designs, and this is very like a nominal price, which is about to $2. Okay, and there are various applications that has been mentioned in the data sheet itself, so this can be like utilized for these applications. However, we are utilizing for our medical systems in CT scan and MRIs. If you wish to quickly evaluate this board without like going for your own design, you can go ahead and choose this particular output, I mean this particular evaluation board, which is going to be eval LTC 7891-AZ. We have also referred this particular evaluation board. However, we have 3 evaluation boards available with you. This is the data sheet that is available, and this gives you a complete picture of, and the best part of this particular thing is you don't need any, I mean, input protection or something like that to start working with this particular IC. Okay, so that's the main advantage of this particular IC to be utilized. Coming back to the circuit design, so circuit design we have very nicely given all the details, like what is the input voltage range and what is the input connectors and all those things. And then we have input protection as well, even if it is not needed, but it is always good to put that. A nice array of a combination of aluminum hybrid electrolytic capacitors, as well as a parallel combination of several ceramic capacitors that has been used as recommended from the data sheet, which makes sure that the input is ripple free. Okay, now coming back to the IC, so IC is this LTC7891, and we have made almost everything very clearly. If you still wish to remove some of the like bill of material costing or something like that, that can always be done. However, it is directly plug in and play solution, so you don't have to do any like changes or something like that. Coming back to the output side, so we have we have utilized GaNFET from EPC. So this GaNFET is having EPC 2067 part number. So these two parts have been used. That's the reason like it is going to distribute the current stress that is going through the switching circuit of like high side and low side. Okay, and this is a die package, so this is very nice package and very well recommended for any designs. We have given you two alternative for inductor as well. So one is from Worth Electronics, which is not being used, and one is from TDK that is being used, which is 2.2 micro Henry. We have current sense resistors and like filters and all these things are there to limit the currents and like sensing the current that is there. So all these things are there in this particular design. Coming back to the output side, we have a nice array of a combination of electrolytic hybrid capacitors as well as ceramic capacitors. You can see we have complete filtering and protection. So we have put a TVS diode as well, so that like we can in any situation we can always limit the output voltage that is going. And this is the output connector that is going to be utilized. Let me see here. So this is the output connector that is going to be utilized. So these two stubs will be used for that. We have several test points that is there, and in the red in this particular board you can see we have several test points put in the middle as well, so that you can very easily test your circuit like very simply. Coming back to the bill of material, so let me just give you a brief introduction about bill of material as well. So as you can see, we have item, then how many quantities of each item, we have reference designators, we have parts. I mean, very briefly you can understand like what is this particular part. Then we have manufacturer part number, we have description, then we have assembly, whether the part has to be assembled on the board or it has to be discarded. And we have PCB footprint as well, so that it's very easy for the PCB layout engineer to make their footprint and complete their PCB layout. All right, so this complete information will be given to you as and when needed. So as you can see, all the parts are taken from standard manufacturers like Panasonic, TDK and all these things. Actually, this particular DC-DC converter has been made in a like goal to utilize in automotive sectors as well. That's the reason all the parts here are AEC like Q200 qualified. Like all the parts are AEC Q200 qualified. Okay. Similar to that, we have like other parts from TDK, Little Fuse, Nexpria, Onsemi. Then we have Worth Electronics. Standoffs are there which can be utilized for giving you the input and output connections. We have inductors. Then we have this is the MOSFET that I have been talking to you, like GaN MOSFET. It is having just like 1.5 milliohms of RDS on, so this is very very good. Okay, and since the output voltage is very less, as well as input voltage is limited to 15 volts, so we have used 40 volt with 60 amperes of rating. Okay, coming back to the all resistors, and like this is the device that is there, that is being used as a GaNFET controller IC. All right. So hope you have now a complete idea about what is the thing that is being given in this particular solutions to you. And if you wish to like get connected and get more insights of it, like what is this particular project and what is this particular product, how it can be utilized for an application of 5 volt 15 amperes output at the input of like 9 volt to 15 volt. If you wish to make any changes or any customization, like if your input is going up to like a 48 volt or something, or maybe 36 volt, this can also be very easily achieved by just changing the part numbers. There is no need of changing any like footprint of any components. That is all every like very easy to do that. All right guys, thank you so much. So enjoy with your like high efficiency GaNFETs DC-DC converter with very high efficiency as needed.